The future of space travel, Mars colonization and beyond. Hey everyone, welcome back to our channel. Today, we're going to be talking about the future of space travel and the exciting possibilities of human colonization of Mars and beyond. It's an incredibly exciting time to be alive, with so many incredible technologies and innovations that are pushing the boundaries of what we thought was possible just a few decades ago. Section 1. The current state of space travel. To start, let's take a quick look at the current state of space travel. Right now, we have the International Space Station, which is an incredible feat of engineering and collaboration between countries. We've also sent probes and rovers to explore other planets in our solar system, such as Mars and Venus. However, human spaceflight beyond low Earth orbit is still a challenge, and we're just starting to see the beginnings of private space companies such as SpaceX and Blue Origin. While the International Space Station, ISS, has been a significant achievement in space exploration, it has also faced its share of challenges. Launched in 1998, the ISS orbits Earth at an altitude of about 408 kilometers and has been continuously occupied by rotating international crews since 2000. The station has enabled a wide range of scientific research in fields such as biology, physics, and astronomy, as well as providing a platform for testing new technologies for space exploration. Despite the successes of the ISS, human spaceflight beyond low Earth orbit has remained a significant challenge. The last time humans traveled beyond low Earth orbit was during the Apollo program in the 1960s and 1970s. Since then, NASA has been focused on launching missions closer to home, such as the Space Shuttle program and the development of the ISS. In recent years, however, there has been a renewed interest in exploring deeper into space. Private companies such as SpaceX and Blue Origin have been developing new spacecraft and launch systems that could make human spaceflight beyond low Earth orbit a reality once again. SpaceX's Crew Dragon spacecraft, for example, successfully transported NASA astronauts to the ISS in 2020, marking the first time humans had launched from American soil since the end of the Space Shuttle program in 2011. Meanwhile, NASA is also working on the Artemis program, which aims to return humans to the Moon by 2024 and establish a sustainable presence there by the end of the decade. The program will also serve as a stepping stone for human missions to Mars and beyond. The Artemis program will use NASA's new Space Launch System, SLS, rocket and Orion spacecraft, which are currently undergoing testing. Section 2. Challenges to overcome. So, what are the challenges that need to be overcome to make human colonization of Mars and beyond a reality? There are several major obstacles that we need to tackle. First, there's the issue of cost. Space travel is incredibly expensive, and sending humans to Mars will require a significant investment. Second, there are the health risks associated with long-duration spaceflight, such as muscle and bone loss, radiation exposure, and mental health challenges. Finally, we need to develop the necessary technologies and infrastructure to support human life in space, such as sustainable habitats, food production systems, and waste management. Cost is perhaps the most significant challenge to overcome when it comes to space exploration. Building and launching rockets, developing new spacecraft, and sustaining a presence on other planets all require substantial financial resources. However, with the emergence of private space companies, there is a potential for reducing costs through reusable rockets and more efficient launch systems. NASA is also exploring public-private partnerships to share the cost burden of space exploration. Health risks are another challenge that must be addressed for long-duration spaceflight. Astronauts on the ISS already face some of these challenges, such as muscle and bone loss due to prolonged exposure to microgravity. However, the risks are even higher for missions to Mars, which could take several years to complete. Radiation exposure is also a concern, as astronauts will be exposed to higher levels of radiation beyond Earth's protective magnetic field. Research is ongoing to develop better ways to mitigate these risks, such as exercise programs to counteract muscle and bone loss and improved radiation shielding technology. Developing the necessary technologies and infrastructure to support human life in space is another significant challenge. On Mars, for example, humans will need a habitat that can protect them from harsh environmental conditions, such as extreme cold and radiation exposure. They will also need a way to produce food and manage waste, as well as a reliable source of water and energy. NASA and private companies are currently working on developing these technologies, such as 3D printing habitats using Martian soil and producing food through hydroponic systems. Another challenge is the psychological impact of long-duration spaceflight. Astronauts will be confined to small spaces for extended periods, and the isolation and lack of social interaction could have a significant impact on mental health. NASA and other organizations are researching ways to support astronauts' mental health, such as virtual reality systems and telemedicine. Section 3. Exciting possibilities. Despite these challenges, there are many exciting possibilities for the future of space travel. Imagine a future where we have established a human colony on Mars, with researchers and scientists working to unlock the secrets of the red planet. We could even use Mars as a stepping stone for further exploration of our solar system and beyond, such as establishing a permanent presence on the Moon or sending a mission to explore the outer planets. One of the most exciting possibilities of space exploration is the potential for discovering new forms of life. Mars, for example, has long been a target for astrobiologists due to its similarity to Earth in the past. The discovery of microbial life on Mars could have significant implications for our understanding of the origins of life in the universe. Another exciting possibility is the potential for new technologies and innovations to emerge from space exploration. Many of the technologies developed for space travel, such as advanced materials and miniaturized electronics, have found applications in other industries. In the future, we could see new breakthroughs in fields such as renewable energy, medical technology, and transportation. Space exploration also has the potential to inspire a new generation of scientists, engineers, and explorers. The first moon landing in 1969 sparked a wave of interest in science and technology, and we could see a similar effect in the future with missions to Mars and beyond. By engaging and inspiring young people, we can ensure that we have the talent and resources necessary to tackle the challenges of the future. Establishing a human presence on other planets could also help us address some of the challenges facing humanity on Earth. For example, space-based solar power could provide a sustainable source of energy for the planet, while technologies developed for space exploration could help us address climate change and other environmental issues. Section 4. Innovations and technologies. To make these dreams a reality, we'll need to develop new innovations and technologies. One promising area of research is 3D printing, which could allow us to manufacture structures and equipment on demand in space. We'll also need to develop new propulsion systems that can take us further and faster than ever before. Finally, we'll need to find ways to recycle and reuse resources in space, such as water and air. Another important technology that will be crucial for long-duration spaceflight is artificial intelligence, AI. AI could be used to automate routine tasks on spacecraft and in habitats, freeing up crew time for more important tasks. It could also help us make decisions in real time based on data from sensors and instruments. We'll also need to develop new materials that can withstand the harsh conditions of space. For example, we'll need lightweight and durable materials for spacecraft and habitats that can protect against radiation and micrometeoroids. Advances in nanotechnology and material science could help us create these materials. Another area of innovation is in the field of life support systems. In space, we'll need to create closed-loop systems that can recycle and regenerate air, water, and other resources. This will require a combination of chemical, biological, and physical processes, and will be a key area of research in the coming years. Conclusion. So, there you have it. The future of space travel is full of exciting possibilities, from human colonization of Mars to exploration of the outer planets. While there are certainly challenges to overcome, we have the knowledge, skills, and technologies to make it all possible. What do you think about the future of space travel? Let us know in the comments below. Thanks for watching, and we'll see you in the next video.